In today's video, we're going to explore the concept of stopping distance, which refers to the minimum distance that is required for a vehicle to come to a complete stop in the event of an emergency. The very first thing to understand is that the total stopping distance is made up of two main components, the thinking distance and the braking distance. Throughout this video, we will examine what each of these components means and explore the various factors that influence them. The thinking distance is defined as the distance a vehicle travels during the driver's reaction time. This is the time interval between when the driver first notices a hazard and when they actually begin applying the brakes. There are two key factors that affect the thinking distance: the speed at which the vehicle is moving and the reaction time of the driver. The faster the vehicle is traveling and the longer it takes the driver to react, the greater the distance the vehicle will cover before the brakes are even applied. Reaction time can vary significantly between individuals and can be influenced by several external and internal factors. For instance, anything that lowers a person's alertness, such as fatigue, alcohol consumption, the use of recreational or prescription drugs, or even just being distracted or not paying full attention, will lead to a longer reaction time. This in turn will cause the thinking distance to increase. The braking distance, on the other hand, refers to the distance the vehicle travels after the brakes have been applied until it comes to a complete stop. Under normal driving conditions, several factors influence the braking distance. The most significant are the speed and mass of the vehicle, as both contribute to the vehicle's kinetic energy, which must be reduced to zero to stop the vehicle. A higher mass or greater speed results in more kinetic energy, meaning more braking force and time are needed to bring the vehicle to a halt. The effectiveness of the braking system is also crucial. If the brakes are worn out, damaged, or not functioning correctly, they cannot apply adequate pressure to the wheels. This will result in a longer stopping distance, as the car will not decelerate as quickly. Another vital factor is the level of traction between the tires and the road surface. Slippery conditions such as wet, icy, or snowy roads reduce friction, making it easier for the tires to skid. Similarly, if the tires are bald, meaning they have little to no tread left, they will not grip the road effectively, leading to a significant increase in braking distance. Now that we understand the variables that influence stopping distance, we need to examine how speed in particular affects it. This is often represented using diagrams that show several cars traveling at different speeds. In these diagrams, each car is shown moving toward the right, and their stopping distances are visually represented with colored sections. The green cars each move at a different speed, the purple sections show their thinking distances, and the red sections show their braking distances. These diagrams typically demonstrate the total distance each car travels before it comes to a complete stop, starting from the point at which they first detect a hazard, usually indicated by an orange line. A key point to understand is that while the thinking distance increases in direct proportion to speed, the braking distance increases at a much faster rate. In fact, if you double the speed of a vehicle, the braking distance will increase by a factor of 4. Similarly, if you triple the speed, the braking distance increases by a factor of 9. This is because braking distance is proportional to the square of the speed. That is why when we graph the total stopping distance against speed, we do not get a straight line but rather a curve that gets steeper and steeper as the speed increases. This clearly shows that higher speeds dramatically increase the total stopping distance. The key takeaway from all of this is simple but crucial. The faster you are traveling in a car, the significantly longer it will take to stop, and it will likely be more than you intuitively expect. Therefore, maintaining a safe speed is essential for ensuring that you can stop in time to avoid hazards and stay safe on the road. That wraps up everything for today's video. We hope you found it informative and useful. If you did, be sure to share it with others, and we look forward to seeing you in the next one.